Hello everyone, how are you all doing? I hope you're doing great. Uh, I attempted to create an encryption algorithm. I know it's not that good, like by the end of the video, you may think this is not like the best. And I have a reason for that is because I'm a digital forensics student. What we work on is like data recovery, inspecting the recovered data. So if you want to create an encryption algorithm, you need to be a cryptographer, and that takes maths. Like you need to know a lot of maths because it depends on complex math equations. Simply, I don't have that. What I did was apply the encryption algorithm programmably. So what we're gonna discuss in this video is how I made the algorithm. We're gonna discuss how the thought process behind it, and I'm gonna tell you like how I'm gonna improve the encryption algorithm, like the challenges and how I'm gonna improve it. I have like really good ideas, actual good ones. So, yep, I think that's about it. Oh, wait, there's something more to mention. The reason I did this encryption algorithm was I was in second year in university, and we took this subject. It's called Principles of Encryption. And I really fell in love with the encryption algorithms. I always loved secrets and stuff like that, passwords. So that's why I did it. And I started back then. So yeah, let's get started. So to start off this code, I did some basic stuff like importing all libraries. I like doing this. No, I don't think it impacts performance. So yeah, and the scanner input. Uh, this is to take the user input, and I just like to name it input. So to start off the actual code, first of all, we are gonna need to read the plain text from the user, obviously. So this will prompt them to enter the plain text. Then we're gonna read three keys from the user. The reason I did three keys because I did the mathematical operations on them. We're gonna see in a bit what you're gonna see in a bit what I mean. But usually there is like a single key, especially this is a symmetric encryption algorithm. There is usually a single key, and its minimum size is 128 bits. And that's not good enough for me because as I said before, this is not done mathematically. I don't have the enough mathematical knowledge to make one key uh, introduce like a complicated plain text that you can't brute force. So I needed multiple keys, and I did multiple simple mathematical operations on them. And the key sizes are 8 bits, 8 bytes, I mean, each, as you can see here. I used the string value of this number because this is an integer, as you can see. And the length method only works with the strings. So I just translated the number into a string and compared it. And if any of these keys aren't 8 bytes, it's gonna tell them it's an invalid key length and you need to enter new keys. Now let's get to the actual hard parts in some way. They're not really hard, but like this is supposed to be the hard part. By the way, excuse my English, it isn't my first language, and I have some trouble speaking, so bear with me. So let's start. First of all, I declared all the variables outside the for loop, this for loop, so I can use them whenever I want. These counts are actually letter counts and space counts, and this is to prevent cryptanalysis, and I'm gonna explain it in a bit how that works. So this for loops is gonna read each character of the plain text. So plain text dot length, let's say it's 10 letters, it stops at 10, and it's gonna read each letter. So letter 0, 1, 2, 3, 4. And these if statements to detect what that character is. So this is space A, B, C, D until the end. So let me go here real quick, and let's say my plain text is wow. And the counters work by, let's say if I didn't have those counters and the output was like 2, 3, and 2. This is bad. This is very vulnerable to the cryptanalysis. They're going to figure out sooner or later, especially if wow is repeated multiple times throughout the plain text, they're going to figure out 232 as well. They're going to figure out the value of W and O and the other W, you know? So that's what the counters do. They detect if W has been repeated more than one time. So if it's repeated more than one time, it's going to have a different value. So let's say, wow, this is like 2. This is after the counter. It's like 2. This is 3. And like this is 7. This is to prevent them from knowing that the letter has been repeated multiple times. So when we go back to the code, let's say that the character is a space. It's going to enter here on this if statement. It's going to enter here on the space count. If it's equals to 0, that means this is the first time that the letter has been repeated. This is the first space in the plain text. So it's going to do some mathematical equations. I know this is not complex by any meaning, and I'm very well aware of that. That's why I made multiple keys to try to make it as random as possible and as big as possible, the printed out value. I need This is my way of patching my mathematical weaknesses uh, by making it like a very big number and a very random number. I'm gonna explain why this is here in a bit. The method abs, what this does is it gives us the absolute value, and you may think that I don't need it, and you would be correct. But before this was here, this was like minus, and I had remainders and stuff like that, and it was difficult to invert. Like when you want to decrypt it, it's hard to invert when it was like minus and stuff like that. And why I added this is because let's say your thing was this, and they're gonna figure out like there is a -9 and that's bad. It's better like to keep them all positive values, you know. That's why this abs was here. Then I needed to translate all of this into a string because I needed it to print only 4 characters. So this, let's say this is wow. It's gonna print like 1, 2, 3, 4, like other value, and 1, 2, 3, 4, 1, 2, 3, 4, wait, 1, 2, 3, 4, and like that. It's gonna print out this, you know. Uh, I needed only to print 4 characters of this mathematical equations. By the way, this is a totally random number. This actually refers to something that I'm gonna be speaking about in the section. I guess I will make this video into multiple sections. I'm gonna discuss this in the part where I'm gonna make this a better encryption algorithm, also programmably. So this prints only 4 characters. Uh, let's talk about the space count. So let's say the space was repeated another time. It won't enter here, it's gonna enter. Wait, before I talk about that, when it enters this statement and prints out a value, it's gonna increase the space count. So when the space is encountered again, it won't enter here, it will start entering this statement. This has different values, of course. It's gonna increase. The reason I placed the space count variable in here is because each time this increases, it's gonna give us a different value. And I also will speak about how I'm gonna make this better. So that will be at the end of the video. This will ensures that each time space is repeated, it will have a different value. And obviously this is not good enough. So let's say space is like 1 or like 0, 1, 2, 3, 4. They are very small values. That's why there's this number. There's other numbers. As I said, I'm not good at maths, and I'm not a cryptographer. So I tried to patch those vulnerabilities as much as I could with the programming and more more random numbers. So, and it's gonna increase the space count again. So now it's like 0, 1, 2, 3, 4. It's gonna keep increasing it. So this is for the encryption algorithm. I'm gonna show you how it works real quick. Let's say uh, I want to encrypt plain text encryption. I'm gonna enter 3 keys. Let's say 1, 2, 3, 4, 5, 6, 7, 8. I'm gonna copy that. Control V, Control V. This is my plain text. I mean, this is my ciphertext. My bad. Each character of the encryption, like E, is equals to like 3015, and it's gonna just keep encrypting each letter, and each repeated character won't have the same output. I hope this all makes sense. And now we're gonna move into the decryption part. Okay, so let's get into the decryption part. This was the hard part. The encryption was like simple. So this is where the good stuff starts, I guess. This is all the same as before, except all of these. This is also the same. I just forgot to put it up there. I'm gonna talk about these soon. So this for loop iterates through each character from the ciphertext. But I I declared the ciphertext as a string because I couldn't take values from the ciphertext, only compare it like the length method only takes strings. So I needed this to be a string in order to take only 4 characters and translate them. So this is where it translates. I mean, this is only where it takes 4 characters and translates them. So if the count is 0, that means this is the first character of the array. I needed to put the ciphertext in an array in order to compare it and translate it again. So this is ciphertext. It's gonna put it in an array. It's gonna be like 1, 1, 1, 1, and it's gonna translate it again into numbers. So count equals 0. This is the first number of the array. First equals character to get numeric value of the ciphertext. This is the first character of the ciphertext. It's gonna get the numeric value because it's declared as a string. It's gonna store it into the first element of the array, and it's gonna increase the count for the second element of the array until it reaches 4, as you can see here. Then it's gonna translate it. The translate variable, what it does, it translates the array into numbers again. And this is what will be used to compare these, like all of this down here. This will be compared to translate each time. Also, I forgot to talk about the reset counter. So after this one, it's gonna reset the count. It's gonna store all of these numbers into the array and translate it. It's gonna translate it, and it resets the count to read another 4 new numbers. So let's just talk about this real quick. This is the ciphertext. A translate will have this value. This is the value of translate, I'm just gonna translate. Let's fix this. So this is translate. Now, right now, it has this value. And this is gonna make more sense later. The reason for this again is because I need to only read four numbers from the ciphertext, and the only way I could figure out, like I tried the stacks, I tried the queues, an array worked for me. I store them into an array. I see if that array is 4 numbers long. As you can see, it's like 1, 2, 3, 4 stored in there. Translate the array into normal numbers again. This is why I need the plus, multiply it by 100, by 1000, by 10. So now translate has this value, and we're gonna start comparing it. So now onto the space character. This is the space, as you can see, it ends here. Now it's the A, B until the end. So the result, this result is the same value as this one right here, and I need that to compare it. So this is the result. I couldn't just do the substring thing here. That's why it's a bit complicated. The substring here couldn't work. That's why I need the result string. If I were to do the substring value here, I couldn't compare it like I tried, and I run into an error. So this is the result string. It's gonna take the string value of result. It's gonna take only 4 characters, as you can see here. Results.string.length. That's why I need the string value. It's gonna check if it's more than 4 characters. It's gonna take. Then it's gonna stop. It's gonna enter the if statement. It's gonna print only 4 letters, and it's gonna put them into the final value integer variable. Variable. Yep. So this is the actual value of the space when it's at count 0. Like if it's not repeated yet, this is the actual value of it. Then it's gonna translate it into a string, check the length, translate into only 4 characters, then translate it into an integer, and finally it's gonna translate with the final value. So the final value is for the space. So let's say space right here has the value 1, 2, 3, 4. It's gonna compare them, compare these values with translate. If it's not, then it means that the character in the ciphertext is not a space. If it was 1111, then it's gonna be a space. It's gonna print out a space. Now for the actual difficult part, as I said, this value is for not repeated letters. So what if it was repeated, like here? This space count equals 0 if it's not repeated. This one, if it's this one, if it was repeated. So that's why we get into this part. If a space count is more than 1 or equals to 1, it's gonna enter here, because as I said here, decreases the count every single time. So if space count is more than 1, same thing here. The result is this, the mathematical equation, without the substring, only the mathematical equation. I highlighted that by accident. It's going to translate it into a string. You're going to see if it's only 4 characters. It's going to check out the result, translate it into 4 characters, final value, translate it back into an integer, and compare it. If translate is final value, it's going to print out a space. It's going to close this one, and it's going to increase the space count. The reason why, by the way, these are the same as this. Like it's gonna keep count of the space count. It's like if it's 0, it's gonna enter here. If it's 1 or more, it's gonna come here to this part, and it's gonna keep increasing that space count in order to keep decrypting it, because as I said, space count is added into the equation in order to make it more difficult to like observe and do cryptanalysis on. So this logic basically goes like the same for all of this, and as you can see, let's say I want to crypt this. So it's gonna be 1, 2, 3, 4, 5, 6, 7, 8, or any different keys. It won't make any difference. This is just to cut the time, I guess. So this is my ciphertext. Let's copy that. Go to the decryption part. This is my ciphertext, my keys. 1, 2, 3. Okay, that works. As you can see, it fully works. And yeah, Now for future plans, I'm gonna make some small changes like here. I'm gonna tell them where is the error, like if it is at number 1, 2, or 3. I'm gonna move this to Python, of course, because my future plans need this code to be translated to Python. I'm gonna make some small changes, and what I want to add is false values, because right now your text is like 1, 2, 3, 4, 5, 6, 7, 8. They're gonna figure out that these are 2 letters. They may figure out the length of your message. So what I want to add is false values. So let's say this. Now they're gonna think your ciphertext is 3 letters when in reality it's only 2 letters. And what I want to do, you see this value. This is not a random value. This is stock price markets for different stuff, different stocks. My future plans is I'm gonna make an API. I'm gonna connect it to like ChatGPT, DeepSeek, or whatever, and I'm gonna ask it for a price market. I'm gonna make like a new integer, like integer price, and it's gonna be connected to the API. You know, let's say if this is integer price, I'm gonna connect it to the API. I'm gonna insert it here. It's similar to Cloudsphere lava lamps. They take random values from the lava lamps and they put it inside their encryption algorithm. That's the same thing I want to do, but with stock market prices. But that will also come with challenges, like how am I gonna like save that value? Is that value gonna stay for a day, an hour? Uh, like it's gonna have multiple challenges, because what if the user encrypted his text with keys for this day and he wanted to decrypt it like the next day, you know? So it's gonna come with multiple challenges. uh, that's like this is my plan for now, is to put stock market prices to make it more secure, you know, because all of these are static. I need more dynamic ones. I'm gonna need to find out a way how to store those dynamic ones and how to reset them. I also have uh, more plans. Instead of like no, it's not instead of anything. It's more of an addition. I'm also gonna increase more variables like stock market, temperature, computer temperature, and more stuff. I think it's gonna be good, but until now I haven't uh, thought of a way of how am I gonna store those variables, my bad, and how are they gonna work. So I'm excited about that part. I hope someone found this interesting, I guess. I know this is not something revolutionary or whatever. This is very stupid, if one might say. But I hope you enjoyed, I guess, and give me your opinion in the comments. Uh, Tell me what I could improve and what not. And this code will be, of course, released on GitHub. So yeah, thank you for watching.